Hello, my name is Victoria Winland, and in this presentation I will be discussing assessing proficiency. And there are 5 strands of mathematical proficiency. The first is conceptual understanding, then procedural fluency, strategic competence, adaptive reasoning, and productive disposition. And these all affect student learning and mathematical modeling. Here we have a question. I have 6 times as many muffins as cookies and twice as many muffins as donuts. I have 170 pastries altogether. How many donuts do I have? Well, how do we solve this? First, we need to find relationships. We know altogether, muffins, cookies, and donuts, we have 170 altogether. We know that there are 6 times as many muffins as cookies, so M equals 6C. Muffins equals 6 times cookies. This could also be written as C equals M over 6. And then we also know that M equals 2D because there are twice as many donuts. And then there are D over 3 cookies for our final relationship. How do we solve this further? We can solve by using substitution combining like terms. So our original relationship is altogether muffins, cookies, and donuts is 170 pastries. However, these are not like variables, so we need to substitute our variables to have a common variable, which we will use D for donuts since we're solving for how many donuts do we have. So 2D plus B over 3 plus D is 170. Now we need to find a common denominator, which would be 3, and change our terms. So 6D over 3 plus D over 3 plus 3D over 3 equals 170. Our next step is to add like terms. So 10D over 3 equals 170, or 10D equals 510, or D equals 51. Now that we know our information, we can create a pastry chart with all of our data. So there are 51 donuts, 17 cookies, and 102 muffins. How do the 5 strands of mathematical proficiency tie into this problem? The first is conceptual learning, and students can prove that they can prevent mistakes, and they can also comprehend what is being asked. They can reconstruct formulas. They know when an answer makes sense, and they can also apply this concept to different purposes and different problems. The second is procedural fluency. They can perform computations both mentally and on paper. They are accurate, efficient in their problem solving, and they can also estimate. Next is strategic competence. They are given opportunities to problem solve. They can perform different solution strategies, and they can also represent their findings. Next is adaptive reasoning, and this shows that students can show their logical thought. They can explain and justify their reasoning. They know the task because it is in a familiar context, so they are motivated to solve. They also have a sufficient base of knowledge and understanding, and they know when to abandon a strategy because it doesn't work or it does not make sense. Finally is productive disposition, and students can see the practicality of the problems they're solving. They also have frequent opportunities to solve and practice. Teachers are able to recognize perseverance, and this shows that teachers are usually the ones that shape the attitude of students in their mathematical problem solving skills. Students also feel accomplished and they know the reward of a problem making sense. And lastly, they see a math as useful, sensible, and worthwhile. In summary, proficiency happens over time, and a skill cannot be proficient if it is underdeveloped and students cannot move to the next strand. And this is true for all ages, grades, and models. Teachers need to be able to make math accessible to their students, facilitate access points. They need to also make multiple representations and ask their students to prove their solution. as well as model strategies and correct errors, so no further mistakes are made. Students also have a responsibility. So students need to demonstrate their understanding, make connections, persevere in their thinking, communicate and explain what they don't understand and what they do understand, as well as accept further challenges. Here is my reference, and thank you for listening to this presentation.